Do you remember how to simplify a square root? Yes. All right. Now, what if I told you there is a possible way that you can do this with your calculator if you are calculator savvy? You'll get there. When you have a calculator, and I'm looking at the square root of 24. Last year you guys would type square root of 24 and it would spit out an answer. 2 root 6. Now you have to go one of two ways. Know what your perfect squares are. Square root of 4, square root of 6, so it's 2 root 6. Or you take a couple seconds and you should do it this way. In your calculator, if you go to your y equals tab, what I'd like you to do is type in 24 divided by x squared. Okay? Y equals this top left button.
Yeah, mine's all faded out.
If yours is faded out, hit, oh, the Y equals button? Yeah. X is right here next to the alpha button. Divided by 24 divided by x squared. Okay? Go to your table. Your table is second graph, top right button. In your table, welcome. In your table, you should see something like that. Obviously, you might have to adjust where your table starts at. It's no big deal. You just scroll up and down to get through it. Obviously, 0 divided, if 0 is x, it's 24 divided by x, hence why there is an error there, because you can't divide by 0. 24 divided by 1 is 24. But here's where it goes. 24 divided by x squared, which means 24 divided by 4. 2 root 6. Once this number in the y column becomes all decimals, the last number that you see, that is a whole number, an integer value, that's what goes underneath the radical. The number out front is the number in front of the radical. So you get 2 root 6. Oh, I get second bracket. Go to the table. Okay? Try it again. Go to the 90. Square root of 90. So go to your y equals table. Your cursor is going to be right on the 24. Just overwrite 24 as 90. To get to your table, you hit second graph. And you scroll through to look for it. Where does it wind up at? 3 root 10. Now, one thing the calculator will not do for you. What's that? Well, yeah, you're right, it's 3, but what I want you to remember, it's going to be, this is 3 and this is the roots. And the answer becomes 3 root 10. That's how you would read it then.
Wait, how? I don't get it.
See how 10 is the last number in the y column before everything becomes decimals? Which means 3 squared went into 90 cleanly. It was this squared is the biggest number that went into 90, and this is what was left over. That's all. That's what it's doing. The one thing the calculator will not do is this. Your old calculators would do that. Yeah? If you took your old calculator, took 2 divided by the square root of 3, you'd get 2 root 3 over 3. But I'm not going to let you use it. You'd be lucky I let you use these things half the time. What you do here when you rationalize the denominator, is something that's been a while. I don't think you'll see a lot of it tonight. But over the course of the next week or so, you'll see a few more of these. You will get better at it. There are shortcuts. You will pick up on them, I have no doubt. Okay? What you do here is you multiply the top and bottom by a factor of 1. What's this denominator? What's the square root of 3 divided by the square root of 3? 1. Correct. So your numerator becomes 2 root 3 over 3. We do a lot of what's called rationalizing of the denominator. Whether it's going to be with just radicals, imaginary values here pretty soon, or conjugates. We're going to even have conjugates of trig functions. It's all the same process of multiplying by a factor of 1. Like I said, you're not going to see a ton of it tonight, but you will start to see this more and more. And as it comes up, I will show you guys it, and I have no doubt it will be fun. Okay? I'm going to party over there. But the question is, though, how do you solve this? 2x squared plus 1 is 17.
Wait, are you actually?
What do we do first? Minus 1. Very good.
Oh, that's not what I was gonna do at all.
Now what do you do?
Divide by 2.
Divide by 2. You have to move everything away from the variable prior to doing what your next step is.
Square root.
All right. What happens when you take a square root over an equal sign? Correct. Whenever you take the square root over an equal sign, when you're doing that on both sides of an equation, it's going to be plus or minus. Another thing you're going to come across and you're going to get really good at remembering, what's the square root of 8?
2 root 2.
2 root 2. What's the square root of 12? 2 root 3. Square root of 18?
2 root 2.
3 root 2. Square root of 24? The square root of 100? Hey!
That was tricky. Like I knew that, but I was still like, oh.
What's wrong?
That one problem was beginning of the year. I don't know. It's like 2, 4, and 6.
246?
It was
Divisible by 3? Be 82. What do you do now?
multiply by 3.
Good. When you multiply by 3, I'm pretty sure enough. When you undo multiplying by a fraction, what is that called? Thank you. Cage, not Eric.
No.
I don't want you guys to say divide by a fraction. This is not do that. That's complicated.
Multiply by
Multiply by its reciprocal. The reciprocal of 1/3 is
3.
3 over 1.
so you multiply both sides by 3. Are you wrong by saying 3 over 1? No. Now what? Now I have to take the square root of both sides because I'm grouped. I can't move the 5 until I ungroup it with the parentheses. Square root, what happens over the equal? Plus minus. So you have x plus 5 is plus or minus square root of 21. I'm going to go out on a limb and say 21 is going to be the square root of 21 because its factors are 1, 3, 7, 21. Where do you put the 5 then? What do you do? Subtract it. So if I subtract it over, do I get the square root of 16 and I get 4?
No.
What?
You just get
What?
the square root of
Wait,
21 minus 5. That's just it.
Proper math etiquette. When you're moving a constant over to something that has a radical, put it in front. -5 plus or minus square root of 21. And the reason why I want to put it in front of it, so that way you don't accidentally draw that square root symbol too big and do what I just did. Oh, 21 minus 5 is 16. Square root of 16 is 4. Yeah. Math. Okay. Put it out in front. When we have variables and imaginaries here, eventually we'll do the same thing. Do it again, I'll make you stand. You're going to kneel. What is he doing? Nothing. All right, that's enough. Let me use some of these. Oh, I already wrote these down. What problems to do? That way I didn't forget. was,
I
yes.
was looking at that picture last night, I was like, wow.
I was. I shaved my head for about 8 years. 7 years. And then I figured, what do you think, I was sick?
Yes.
I wasn't. We
You were
did
obviously
a,
going through chemo.
it's not funny to really joke about.
Okay, and
I want you to do page 67. I think it's 12, 9, 12 problems like this. It's section 5.3, it's page 267. I'd like you to do numbers 54 through 65 and 68. Okay?
is there a reason for specifically 68?
Because it's fun. Okay? Make sure you put your answers in simplified radical form. There are no decimals. Fancy, isn't it? It is fancy schmancy. Is yours colored?
Man, I really want some.
Same one. Okay.
Mine's better.
No, his is better. Okay, Mr. Murphy.
You're not You're not in the rap. You have your own.
You went out your own.
What's that kid's name that you were just talking about?
Oh, Mr.
What's no?